him. Kill the guy now. You have to come. Hit him. What's wrong with you?
What? What is this?
Good day, sir.
You are watching Jackie Pan in my house.
No, it's King Kong, sir.
Eh? King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense on.
Good day, class. On the first online lecture on MTH 201. Before the break, we were discussing sequence and series, and we were able to define the types of sequence, the types of series. The last class, we discussed we started the properties of power series. And don't forget, I said the power series can be used to expand the function or the sequence given to us, either in trigonometric ratio or the analytical function. Yes, last class we were able to show that 2 cos x is the same thing as cos x plus cos x. From the power series expansion of cos x, we have been able to show that. But this afternoon, we are going another example. We are going to another example, and the example says we have to show that 2 sine x cos x is equal to sine 2x. This is a trigonometric identity, and we want to use the power series to show this one. And what are we going to do in the solution for that problem? The solution for this problem, we are going to know what is sine x and what is expansion of cos x. Then after that one, we are going to go multiply it by 2. Don't forget, I will have to say, we'll recall that sine x is equal to x minus x cubed over 3 factorial plus x raised to power 5 over 5 factorial minus x raised to power 7 over 7 factorial, and so on and so forth. Don't forget, this one can be expanded to plus x raised to power 9 over 9 to infinity, while cos x is 1 minus x raised to power 2 over 2 factorial plus x raised to power 4 over 4 factorial minus x raised to power 6 over 6 factorial, and so on. Having this and this, then what is sine x cos x? Sine x cos x is just like we want to multiply sine x and cos x. So when we multiply sine x and cos x, what we know to do is to multiply this expansion by this expansion. Then we have sine x cos x to be equal to x minus x cubed over 3 factorial plus x raised to power 5 over 5 factorial minus x raised to power 7 over 7 factorial, and so on. And I will multiply it by 1 minus x raised to power 2 over 2 factorial plus x raised to power 4 over 4 factorial minus x raised to power 6 over 6 factorial. So we multiply these two. But in my expansion, if I want to multiply this thing, you know, if I multiply this 1, 2, 3, 4 times by this 4 times, I'm supposed to get 16 times. In which, if I multiply this by this, I'll be getting something like x raised to power 13, x raised to power 14. I don't need that. What I will need to do is, I will multiply all this by this, and I will pick the power of 7, the highest power of 7. Whenever I multiply any terms here by this, and I get to power of 7, I will stop. That's what I want to do. Then, if I multiply this one, if I multiply this by this, I will get x. This by this, I want to use x to multiply this. That's what I mean. Use this x to open this bracket. Minus x raised to power 3 over 2 factorial. This and this x to the power 5 over 5, no, over 4 factorial. This and this is minus x to the power 7 over 6 factorial. I will come to this one and this. If I use this to multiply this, I'll get minus x to the power 3 over 3 factorial. You can see this and this are here. Then I will go to this one, will give me minus plus this times this. X to the power 5 over this 3 factorial, this 2 factorial. That's 3 factorial, 2 factorial. By the time I multiply this by this, I will get plus minus x to the power 7 over 3 factorial, 4 factorial. If I pick this and this, I'll get plus x to the power 5 over 5 factorial. This and this will give me minus x to the power 7 over 5 factorial, 2 factorial. If I pick this and this, I will get raised to this, and this will give me 5 plus 4, making 9. I will not pick that one. I will stop at the power of 7. If I multiply this one by this, I will just pick only minus x to the power 7 over 7 factorial. Don't forget, it's continuous. All the expansion here, there are some expansion here that we've skipped. Then from that, let us combine the ones that are alike. The one that are very alike, this one can give us x minus x to the power 3 over 2 factorial. This 1 factorial, 2 factorial, this 3 factorial. Isn't it? This 3 factorial will give us minus x raised to the power 3 over 3 factorial plus x to the power 5 over 4 factorial, which is this, plus x to the power 3 over 3 factorial, 2 factorial, plus x to the power 5 over 5 factorial, this one, minus x to the power 7 over 6 factorial, minus x to the power 7 over 3 factorial, 4 factorial, minus x to the power 7 over 5 factorial, 2 factorial, minus x to the power 7 over 7 factorial. Yes, though this one will continue. You will discover that there are some of the factorials here that are not in my expansion. And there are some of my factorials in my expansion that are not here. It means there are some that I skipped in my, if I expand it, this thing will be very tall. So it will be very long. So, and that long will make no sense. Then I have to pick the one that I need. If I pick the one that I need from that area, this one can be equal to, this one can be equal to x minus 4x to the power 3 over 6. Where did I get that one? Look at this and this. 2 factorial, 3 factorial. By the time I add these two, it will give me 2 raised to power minus 2x minus 2x raised to power 3 over 2 times 6. This 3 factorial is 6. This 2 is 2. 2 factorial is 2. So that 2 will divide these 2. Then this one will come. Then another 3 factorial that has 3 and 2. Can you see? This plus 1. Another 3 factorial that have 3 and 2. Okay, those are the 2 that I will use there. So by the time I add all this one, I will get this. Then plus 16 x raised to the power 5 to the power 5. All the one that have raised to the power 5 in my expansion. I will get this because look at the base. This is 5 factorial. This is 4 factorial. This 4 factorial is 24. This 5 factorial is something like 1. By the time I add this one, it will divide, it will give me that one. And minus 64x to the power 7 over 5040, and this one will continue like that. But this one, 2 cos x sine x, is this sine x or cos? Okay, either I write it as sine x or cos x. Sine x will be equal to 2 into x minus 4x to the power 3 over 6 plus 16x raised to the power 5 over 120 minus 64x raised to the power 7 over 5040, and that will continue. So after that one, if I use these two to open this bracket, if I use these two to open this bracket, I will get 2 minus these 2 and this 6, they give me 4x raised to the power 3 over 2, no, over 3 plus, by the time I multiply it, I'll get 16x to the power 5 over 60 minus 64x to the power 7 over, if I use 2 to divide this one, I will get, okay, let me multiply direct. I'll get this one 2x, 8x over 6. I'll get this one 32x over 120. I'll get this one 64 times 2 will give me 1280 over 5040. Sorry, 5040. And that will continue. Then this one is named as 2x minus 8x to the power 3 over 3 factorial. This thing is 3 factorial. 6 plus 32x raised to the power 5 over 120 is the same thing as 5 factorial minus 128x raised to the power 7 over, this one is the same thing as 7 factorial. Confirm 7 factorial is 5040, and that one will give us 2 sine x cos x. Let me label it equation 1. But what is, look at sine 2x. Now come here. Look at my angle here. Angle here is what I use to expand this x cubed, x raised to the power 5. Can you see? So instead of x, my x now is 2x. Then that one will give me 2x here minus 2x raised to the power 3 over 3 factorial here plus 2x raised to the power 5 over 5 factorial minus 2x raised to the power 7 over 7 factorial. Instead of my x is now 2x. Then this one will give me 2x minus, if 2 raised to the power 3 will give me 8, and x raised to the power 3 over 3 factorial. X raised to the power 5 will give me 32. X raised to the power 5 over 5 factorial. X raised to the power 7 will give me 128. X raised to the power 7 over 7 factorial. Look at equation 1 and 2. They are equal. It means since 1 is equal to 2, hence 2 sine x cos x is equal to sine 2x. And that is that. But after that, we can let us look at this brother. This one is very important for us. Simplify exponential x over 1 minus x in power series. We just remind ourselves, don't forget what is exponential x. As solution, what is exponential x? We have expanded exponential x to be 1 plus x raised to the power 2 over 2 factorial, x raised to the power 3 over 3 factorial, and so on, and x to the power n minus 1 over n minus 1 factorial. That is exponential x. But don't forget, exponential x over 1 minus x can be written as exponential x over 1 minus x can be written as exponential x multiplied by 1 over 1 minus x. Then what is 1 over 1 minus x? Use any method to do this one. You can use long division method. You can use Maclaurin's method. But for this level, use long division method where the one you did in a partial fraction. When you have this one, you have 1, you have x minus 1. When you do that one, you will get the value that I want to write, you will have it here. And that is what we call the quotient. So if you expand that one, I will get that one to be 1 plus x squared plus x raised to the power 3 and so on and so forth. That is the answer that will get there. Then exponential x over 1 minus x now is equal to, as I said, multiplied by 1 over 1 minus x. From that angle, I will now multiply what I have here, 1 plus x raised to the power 2 over 2 factorial plus x raised to the power 3 over 3 factorial and so on, plus x to the power n minus 1 over n minus 1 factorial, and I will multiply it by 1 plus x squared plus s cubed and so on, plus s cubed and so on. So if you multiply that one, I don't know, just use this to multiply this. But forget about this last expansion. This is the nth expansion of this exponential. I can overlook it. Because this exponential is finitely differentiable function. That is why I did that one. Then this one may be equal to 1. If I use this to multiply this, I will get 1. If I use to multiply this one, I will get x. If I use this, I will get x squared. Don't forget, if I come back, this one to multiply this, I will get x. From the x that I got from this one before, then it will give me 2x. This one to multiply this one, I will get s squared. The s squared that I got here when I will use this one, will get 2x. That is what we will do to get this next step. Then this one will give me plus 2x plus 5s squared over 2 plus 8x to the power 3 over 3 and so on. I didn't write factorials to all this one. This one is 5, good. This number here was not 8. When you expand and open, it was not 8. Because this was supposed to be 3 factorial. That is 3 times 2 times about 2 has divided something here. That is when this one is 3. Then, that is the expansion of that brother. Yes. I will now revise something I told you last time. No, when we are discussing mean values theorem, I told you about one man Taylor. And I wrote Taylor expansion for you. Now I want to rewrite it and we apply the Taylor series. And that we call Taylor's series. Taylor's series. There is theorem there, but the theorem was there in your note, and I said if our f of c will be equal to f prime of a plus b minus a square prime of 2 factorial plus b minus a cube yes, that is Taylor's expansion. And from this one, don't forget this a is the limit about which you were given to expand your function. The limit you were given at which you will use to expand your function. And I said, when we get to Maclaurin, I said this a will be equal to 0. That is why. And don't forget, this one was given to us as the limit of a and b. Now I can change my function to function of x. I can change my function to function of x. So don't be surprised if you see me written this brother as this one, and I'll have limit x tend to a, or let me even write x tend to x naught, and I'll have f of x naught plus x minus x naught, f prime of x naught, and so on this expansion. Now my function is x, then my limit is x naught. Don't forget, I will say this function approaches a limit if this x naught exists. Okay? In that case, and Maclaurin's, okay? Because of our time, I will do only Taylor's expansion. I will do examples, and I will see what we can do later. Let me see an example. Expand f of x is equal to square root of x about x naught is equal to 1. About x naught is equal to 1. Okay, let me write, because in the exam, I will not write what we do. In the exam, I will not tell you by Taylor series. I will just tell you expand it about this point. Once you know that x naught have a value, then it's Taylor series. If it is Maclaurin series, I will not give you any limit of that function. Then from that area, what we need to do, our f of x is equal to square root of x, which is the same thing as x raised to the power 1 over 2. I will not put my limit. What is f of 1? My x naught is 1. F of x naught. What is my f of 1? What is the square root of 1? Then I will differentiate this brother once to give me 1 over 2x raised to the power minus 1 over 2. Some people will say at me, differentiate this one. I will not come to that one. You have done that one in 101. F prime of 1 to give me 1 over 2. What I want to do is that I will put 1 here. If I put 1 here, 1 raised to the power minus 1 over 2 is 1. Then this one will give me 1 over 2. F prime prime of x will give me minus 1 over 4. This one multiply this one. X raised to the power minus 3 over 2. Minus 3 over 2. And f prime prime of 1 will give me minus 1 over 4. By the time I put 1 here, all this one will be 1. And will give me this one. Then you can expand it as much as you like. Let me do the third one. X. If I use this to multiply this, it will give me 8. No. This 3 times 1, 3 over 8. X raised to the power, if I take away minus 1 here, that is 3 minus 2 minus 5 over 2. Then f prime prime of 1 will give me 3 over 8. 3 over 8. If I have that one, I can substitute this value. You can get to 9, you can go to 20 times, but I will stop here. If you stop here like this in exam, you are good to go. I will just I will substitute all this in this function. I will now have my square root of x to be equal to, what my f of x naught, that is 1. This one will give me plus, because it's positive here, minus 1. My x naught is 1. My x naught is 1. Multiply by 1 over 2, which is this brother. To this brother now, plus minus, because of this negative, x minus 1 multiplied by 1 over 4 times 1 over 2 factorial. This one will give me square plus x minus 1 raised to the power 3 multiplied by 3 over 8 times 1 over 3 factorial, and so on. Then this one will give me 1 plus 1 over 2 into x minus 1. This one will give me minus 1 over, this one is 2 times 4, 8, x minus 1 square, plus, this one will give me, this one is 3 times 2 times 1. This 3 will divide this 3. Then I will have 2 times 1. Then the one will give x minus 1 raised to the power 3. Oh, let me write the value first. I write 1 over 8 times 2. 16 x minus 1 raised to the power 3. And so on. And that is the Taylor expansion for that product. So, if you want to use Taylor expansion, just go that one, and that is all. Let us go to, in 2 minutes, let us discuss Maclaurin's expansion. The only difference between brother Maclaurin and Taylor is like somebody come from abroad, somebody come from Nigeria. You know, in Nigeria we have all good facilities and everything, but in America they don't have. So this one is in Nigeria, that one is in America. So is that I want to expand this limit again. This limit x tend to x naught, but this x naught can be equal to 0. If this x naught is equal to 0, my f of x will not be equal to f of 0. Can you see that of f of x naught plus x, because x minus 0 will give us x, f prime of 0 plus s square, f prime of 0 over 2 factorial plus x to the power 3, f prime of 0 over 3 factorial, and so on. Now, the difference is x minus x naught. X naught is 0, then it will go. Example. Expand e exponential x using Maclaurin's series. Sorry, this brother is called Maclaurin series. This function is called Maclaurin series. So we want to use that Maclaurin series to expand exponential x. Now, solution. We want to use that one. Look at our f of x is exponential x. Now, what is, can you see here we are not given about x is equal to what? X naught is equal to 1. There's nothing like about here. It means our point of convergence there is 0. Then f of naught will be exponential 0. And what is exponential 0? Is 1. Anything is power 0 is 1. Then f prime of x is exponential x. Differentiate exponential x, you get the same answer. Then f prime of 0 is equal to exponential 0, which is 1. Then what is f prime prime of x? That is exponential x. F prime prime of 0, that is 1. The third derivative of this function is the same thing as exponential x, and f prime prime of 0 is equal to 1. This is a unitary differentiation. It can never change. When we continue to differentiate 1,000,000 times, we'll get the same answer. Then from that area, we can substitute this in this formula. We now say exponential x is equal to, look at the first one is 1 plus x, because f prime of 0 now is 1. Okay, times 1 plus s cubed times 1 over 2 factorial plus, no, this is s square, s cubed times 1 over 3 factorial, and so on and so forth. And this is 1 plus x raised to the power 2 over 2 factorial plus x raised to the power 3 over 3 factorial, and so on. Compare this brother to the power expansion we did last time. Compare this one. You will see that they are the same thing. Now let me give class assignments. I will collect it when we resume to school. Assignment. Sorry. So let me give assignments. Okay. Using Maclaurin's series to expand 1 sin x, 2 cos x, 3 sin 2x. God bless you.
Finish him. Kill the guy now. Round you go. Beat him. What's wrong with you?
What? What is this?
Good day, sir.
You are watching Japan in my house.
So it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you've been fighting kung fu in your dream. That's the reason why you have F's in your courses, like especially made for you.
I have last semester.
We eat by pounds for you. Very stupid. Oh, yeah, change that section to ACTV right now. And oh God, the baby to have been first born. Stupid boy.